All right, go for it.
And interaction. Oh, sorry. Start sooner. So let me, how should I? Oh. Sorry, I had to close it to image. Okay, so we had that problem of the lags in our dashboard, so we wouldn't be able to scroll smoothly between teams and months in the calendar. And also in the list of the events, we couldn't scroll between different teams. It has too many delay between changing the teams. So with my experience, I thought it would be a memory leak problem. And I searched about it and tried to find those memory leaks. But it wasn't memory leak. So I go do some more research and found out that memory leaks are a small sub problem in the hangs. So if the app stuck in main thread and the UI wouldn't be as smooth as possible, it's a problem in the main thread. And memory leak is one of them, as when we are using the resources very bad, we have the problem of memory leak. So what are hangs? As they call it in Apple, when we see something is laggy, something is stuck, or it's slow, it's a hang in our application. So they have, they call it the main run loop. Each run loop is containing of 3 parts: the interaction of the user with the app, and then a process, and after that, update the UI if it's required. As you see, the purple one is the interaction, and the blue one is the process, and then updating UI. So the main thread contains many of these as a buffer after each other. So if one of them takes a longer time for the process, we will have the hangs. So this will cause the delay of seeing the update UI for the next interactions too. So if the app is stuck in some places and we try to do something else, it will add to the buffer, and this will happen very slowly than we want to do it. So at this time in the app, it is stuck at the processing time, and it will cause the hangs we see. So anything is more than 1 second would call a hang. So if we try to do more stuff with the app as it's a buffer, it will make it even worse when we have it in our app. So it's also a matter of it also will we will call it hangs if it's a shorter delay, but in different occasions. So the same half-second delay in a part of the app would seem like a hang, but in some other places it wouldn't be noticeable because we are changing the views, we are showing an alert or some different pop-ups, so it wouldn't be noticeable. But if it's the user is interacting with the app and doing something else after that, it would be noticeable as a hang. So then we need to find them and eliminate them. So what caused the hangs? There are 3 main reasons. For example, if we are doing some stuff proactively with the app, so we are doing many getting images. For example, our app showing 4 images and it's a list of images. So we are at the same time show only 4 of them. But if we try to load 10 images at the same time, it will cause some hang in our app. So we can load them with that pagination H4 image at the time. So we wouldn't be blocking the UI thread. Also, if we perform some irrelevant stuff on the main thread, for example, the REST API request or some calculations in the UI thread, it will block the main thread and cause that longer processing time that we needed. And also there's a third reason, which is when we use some wrong APIs. For example, there is 2 different ways for putting a corner on a view. So if we use one of them, that may cause some problems, some more times and using the resources of the application much more than expected, it will cause the hangs. So after we find them, we need to try to solve this problem. And one of the ways of finding them is using the instrument in Xcode. So in the iOS app, we have something like this, we call it instruments. It shows different processing and different actions it's happening. And as we see, this a specific function took more than 4 seconds. So it would be called as a hang in our app, and we need to investigate why this function is taking longer time than needed. And also, if it is normal to be 4 seconds, we should put it on the background thread and show the updates in the main thread, so it wouldn't block the UI thread. So in the case we had in our application, I tried some different ways to fix and eliminate them. So the first one was that I put the REST API calls in the background thread and come back to the UI thread for updating the UI. So it solved a little bit of those problems. The next thing was that in the first loading of dashboard, we were loading all of the team's data at once. But by changing the UI selected tab, there was a for loop. We choose this tab for this team, and then for next one and next one. And at the end, we choose the first tab again, so the users see it like normal. But it was calling all these APIs at the same time on the main thread, and it was blocking. So it was the reason for the initial delay we had in the app. Also, the library we used for the tab bar we had in Teams, it was outdated and archived in GitHub repo. So I thought it would be good to replace it. So I removed it from the app and build that part from scratch. So I guess this was the thing that fixed many of those hangs in our app. And the last thing I changed was that every time we scroll to different months or different teams, we are calling a new request. So if the user try to change the month very fast and scrolls between different months at the same time, it will send many requests. So I thought it would be good to cancel those requests for the old months. So the user don't want to see that result. So we cancel it, and it would also lower the loads of our servers too. And this is the reference I used for this presentation, the stuff that I showed in the images.
Nice. I had a question actually about so you mentioned that it's user interaction with the UI, and then processing and then updating the UI. I know things more from like a game loop perspective. Is this continuous, or is this just a response to an user interaction? Is this kind of discontinuous?
It is continuous. Each time you do something with the app, it happens. It happens for every single interaction we have with the app.
Right, but it happens on an interaction. It doesn't happen if there is no interaction.
It happens if there is an interaction, or if there is some processing in the background, but it is also that part of an old interaction at that moment. For example, we do something, we don't expect to anything happens now, but there is a background process, and in the future there would be a UI update for it.
Right. Okay. Yeah, that makes sense. Yeah, I'm more used to kind of the game loop idea where you have this happening, every 50 milliseconds statically, and then it'll check for user interactions every 50 milliseconds, but it'll still keep updating in case you have to update kind of game objects in the background. So a little bit different than that.
Yeah. Okay.
And you said there can be multiple of these? How does that work?
So multiple of UI threads?
Yeah. Do you have multiple overlapping ones, or is it always just one that's happening?
I guess there is only one main thread in the app. So those things are in one thread, and the other threads are those those one we use for the process and other stuff in the background.
Right. Okay. Anybody else have questions? No, I liked it. It was good.
Yeah.
Thanks.
It's always fun
it
to
was
see.
too bad that no one has question. Has no question.
I like seeing a bit into the other systems. It gives me a better intuition on kind of how things work and how we can integrate them.
I have a question which is not totally related to the topic. So in Android, something similar happens for various reasons. One of them, though, is that the garbage collector gets called on the main thread. So, for example, if you're going to create a frame, but like if you're like maybe 60 frames per second, something like that. If during that frame the garbage collector is called, maybe you might miss some frames, so you might see a lag, something like that. Although I think in newer Android versions, the garbage collector is not called on main thread, something like that. So I was wondering what happens in iOS, Swift, or Objective-C. How is the garbage handled? Where is it handled?
I don't remember the exact name of it, but we have something that tries to collect the stuff from the memory. So if the view deinitiated, it will try to remove them from the memory. But there is something we call it return cycle. If there is a strong reference between a view and its subviews, it may stuck there in the memory. And that was the reason I thought it would be a memory leak at the first moment, because I thought it may be deinitialized when we choose different team and it's not removing it from the memory. And let me find the name.
So you have garbage collectors in Swift or not?
Yeah, exactly. We have one, and I'm trying to find its name. I don't remember it. It is automatic reference counting, ARC.
Thank you.
It's fun because it's so different than server or front end processing. You know, server is always done on kind of a per request basis. There's no continuous UI. There's no continuous state. And then front end is just, it runs whenever the website is loaded, and then on timers or timeouts. So it's a very different processing system. Yeah. Any other questions? Any other comments? Did it inspire anybody else to do a tech talk next time on something?
Ethan, what happened to the memory leak you had? Did we find it? Did we find it?
No, it's still going. So this is somewhere where we have set the. Let me stop this.